Hello, everyone. A hot topic today is on blood flow restriction training use in resistance training for strength and hypertrophy adaptations. A lot less studies have used BFR application in aerobic training. I am Dylan Lange. In collaboration with Mr. Osborne and Dr. Kushnick, today I will be presenting on an aerobic BFR training study that utilized treadmill walking and sought to assess the effects on insulin. So again, the year is less BFR aerobic training studies overall. These studies have seemed to indicate positive performance outcomes, such as those in VO2 max, aerobic power, time to fatigue. It is believed that this is due to less muscle oxygenation, which increases intracellular energetic stress, which has responses in both enzymatic and hormonal adaptations. So therefore, this study will assess the effects of BFR aerobic training on blood glucose, insulin, body composition, VO2 max. This was an experimental design where we used VO2 max and BOD-POD to screen for participants. We wanted average fitness and body fat. Those that qualified for the study 72 hours later were induced to a meal challenge. The meal challenge consisted of honey buns and chocolate milk, consisting of about 60% carb, 25% fat, and 15% protein. So the average individual, 64 kilograms of fat-free mass, they would be consuming 960 calories. The meal challenge was taken in the fasted state. So blood samples were taken fasting, and then again 1, 2, and 3 hours after consuming the meal. At the end of the study, after completion of 10 training sessions, the participants then completed these variables in the opposite order. So they had 72 hours to recover after training, where they underwent a meal challenge, where again blood samples were taken fasted 1, 2, and 3 hours after meal. The next day after recovery, individual underwent BOD-POD and again VO2 max without BFR application in the VO2 max testing. The experimental portion of our study consisted of 10 treadmill walk training sessions that were induced to about 50% maximal intensity and lasted for 20 minutes, with about 2 to 3 days of recovery for an overall about 4 to 5 weeks training session. The control consisted of 6 individuals, where the experimental was 6 as well. The experimental had blood flow restricted cuffs applied to the proximal portion of their thigh and inflated to 200 millimeters of mercury, whereas the control did not have BFR application at all. What we found was no body composition, VO2 max, or glucose changes. However, the big thing our study did see was a change from pre to post in the BFR group on insulin responses. So in the table, you can see in the black or on the dotted black line at the very bottom, you see that this is our post BFR group, which is lower compared to all time periods in both fasting and 1, 2, 3 hours after meal challenge. Again, this is our area under the curve. What you can see in the black, we have our BFR group decreasing after 10 training sessions of BFR aerobic training compared to the control, which stayed about the same. So this study adds to the literature on BFR aerobic training with less of a focus on performance outcomes. Our study did not see changes in glucose response, which is not surprising, as other studies seem to indicate longer duration is needed or a population like those with diabetes. Additionally, our study did not see changes in body composition, and those studies, non-BFR studies, do not seem to indicate changes in glucose responses in the absence of body composition changes. Now, our insulin response was a significant decrease in both fasted and postprandial after meal state. It's possible that this was due to the upregulation of GLUT4 translocation, as well as possibly a greater maintenance of the concentration gradient that increased the flux of glucose into muscle fiber due to this increase in GLUT4 translocation. So overall, our study saw at low intensities and short durations in a healthy population, BFR aerobic training can influence the fasting and postprandial responses in insulin concentration. Here are some references, and thank you all for your time.